Right, T1, domain and range of exponential and logarithmic functions. An exponential function is, have you ever heard of anything growing exponentially? It kind of starts off slow and then it just kind of takes off. The good thing about these problems is it's going to tell you if it's exponential or logarithmic. If you are ever asked what is the domain of an exponential function, it is always going to be all real numbers. There will not be anything to talk about, think about, or do anything about it. It's always going to be all real numbers. The reason for that is the domain is always talking about the x's, and x's go left and right? So if I can go here, I can keep on going to the left. It's just going to get a little bit smaller and a little bit smaller and a little bit smaller. And I can go here, and I'm always going to the right. So I'm not worried about up and down when it's talking about domain. I'm talking about left and right. And those arrows always keep on going. So for domain of exponentials, it's always all real numbers. Okay, I'm going to skip this one and find this one. So range of exponentials. Range of exponentials. So for the range, we're talking about the y's. Now, if it is an exponential, there will be some kind of range. And what that does, it's going up and down, right? So this one, okay, it's going up, up, up. It's never going to stop going up. But on the down, it's going to keep going down, but it's never going to pass this horizontal asymptote. It's never going to cross this vertical or horizontal asymptote, and that asymptote is at y equals -6. Everything, all of the graph is above y equals -6, so it's going to be this one. It's not going to ever be equal to, because it's never going to get to -6. It's just going to get closer and closer and closer to it. So on the range of exponentials, it's either going to be y is less than or y is greater than, but it's never going to have the equal sign with it. So that may be a way for you to deduct on that. All right, now let's go, let me see. Okay. Now these, I know I'm skipping around. This is a logarithmic. A logarithmic graph or equation is the inverse of an exponential graph or equation. On the exponentials, your asymptotes are always going to be horizontal. Okay, and you're either going to have this or something like that. Okay. Now, for a logarithmic, your asymptote is always going to be vertical, so your vertical asymptote. So if they are inverses and the domain of an exponential is always real numbers, remember inverses whenever you switch your x and y, and your y becomes your x and your x becomes your y. If this is exponential, then this is logarithmic. If the domain is always all real numbers for the x's, that the range, because it's switched in that spot, is always all real numbers for logarithmics. So the domain, let me say that one more time. The domain of exponentials is always all real numbers, and the range of logarithmics is always all real numbers. We're not talking about that right now. We're talking about domain. So remember, domain is x's going left and right, Well, this is going to keep on going to the right, but it kind of has a wall there to go to the left. And where is that wall at? That wall is at 9. Is the graph to the left, which would be make it smaller than 9, or to the right, which would be greater than 9? It would be to the right, so it's greater than, and it's never going to have that equal sign, so x is greater than 9. Let's go back up. So again, if the domain of an exponential is always all real numbers, then the range of a logarithmic is always all real numbers, because it's going to keep on going up. Not very fast, but it is going up, and it's always going to go down like that. So it's always all real numbers. Let me see if okay, so here we are. I want to keep that in mind. Domain exponential, all real numbers, that's done, because you can put anything into this problem, into the x, and be able to do the answer. You'd be able to get an answer. The range, domain exponential, the range of logarithmic, all real numbers. If you see those two words, then it's always going to be that, and you don't have to worry about it. Okay. The domain and range of an exponential. So the domain of an exponential is all real numbers. All real numbers, so it's not that one, and it's not that one. Now the range, how are we going to find the range if we don't have the graph? This number right here is going to tell you where to start. The sign of this number is going to tell you which way to go. So there is no number right here, so we're going to start at 0, and this is positive, so we're going to go up. So 0 and going up, and not at 2. So it's going to be this one. Domain and range of a logarithmic. It's logarithmic because there's a log right there. And so remember, the range is always all real numbers. This one's kind of easy because you're never going to have all real numbers on both sets. But let me tell you why this is greater than 0. So on this, usually there's going to be like parentheses there and maybe a number with it, maybe +3 or -4 or anything like that. So what makes this 0, 0, so that's where you're going to start. And again, the sign is going to tell you which way to go. So since it's positive, we're going to go up. And so x is greater than 0. Exponential. So all real numbers and all real numbers. And the 8 is how we know what the range is. Okay. All real numbers, so it's not these two. What makes us 0? Five, and this is the only 5, so I don't really have to worry about the sign. But since this is positive right here, it's going to be greater than. Okay. 2 more. Exponential, so domain, all real numbers and all real numbers. And 7. So both of these are 7s. This one has an equal sign with it, so I know it can't be that. But why is it going to the less than 7? Because this is a negative right here. So that makes it less than. So what's this answer? And all real numbers is never going to be that one. So yes, I do know it's going to be that one. But if it's x plus 5 to equal 0, I'm getting that from right here. Here's your negative 5, which is right there.